I am erasing this part. Now this was about joint A. Okay, this is joint A. Now coming to joint F, I can now come to joint F. So here AF is acting in this direction. So for equilibrium, AF should be in this direction at this point, right? So AF is like this here. This is R1Y, right? And this is AB, right? So for equilibrium, at this point, AF should be in this direction. So this is my member AF, right? So force AF, if it works like this, then my member AF, that will be in equilibrium, isn't it? Am I correct?
Yes.
So here I have taken AF. Okay. Say now BF acts in this direction. BF acts in this direction, and say EF acts in this direction. Say EF acts in this direction. Now here again I apply condition of equilibrium. I have already, at this point, I have already found out AF, right? Again, if I now apply summation Fx equal to 0, summation Fy equal to 0, I can find out all the forces, right? So I solve joint F. After that, in step 3, let us come to joint B. Okay, so load L is acting here. Now AB will be acting in this direction here for equilibrium, correct?
Yes.
BF at joint B should act in this direction, correct? And say BC acts in this direction, and say BE, it acts in this direction, say for instance, right? So now I have this BF, I know that here, I know BF. L, I know that here, right? Now if I apply conditions of equilibrium, then the vertical component of BE plus BF, that should be equal to L, and summation of horizontal component of BE, BC and AB, that should be equal to 0. Now AB also I have already found out in joint A. So I just take that force here. What are the things known to me? BF is known to me here, AB is known to me, L is known to me, right? So 3 forces are known to me. I can easily find out BE and BC. Clear?
Yes, sir.
Next I move on to see joint E. Next I move on to joint E. I move on to joint E now. See here, this EF, it is acting in this direction. So here I will take EF in this direction. Clear? I will take BE in this direction. Okay?
Yes, sir.
And say DE, say acts in this direction. Okay? And say EC here. Oh, say EC here, say that acts in this direction. Clear? Now EF is known to me, BF is known to, BE is known to me. From that I can find out EC and DE. Now when I move on to joint C, right? So here I have BC, it should be acting like this. EC should be acting like this. And in this direction you have C to D, right? So EC, from this joint analysis, EC is known to me. From this joint analysis, BC is known to me. So I can easily find out EC. Correct. Now I move on to joint D. So here I will be having CD. Here I have R2, and along this direction I should be having DE. So in this manner, I will move on to each and every joint and I can find out the force in each member. Is it clear to you?
Yes, sir.
So, in this,
Yes.
in this, we can conclude that all the forces must be in equal and opposite.
Yes, of course, because they are two force members.
Yes, sir.
Two force members. So in two force members, for a two force member to be in equilibrium, the force should be collinear. Preferably, it should be collinear and in opposite direction, isn't it?
Yes, sir.
So it should be equal and opposite. Say F and F like this for this two force member to be in equilibrium. Clear?
Yes, sir.
Right. So this is how we should be solving. Now coming to an example. Okay. So this is example 1. Determine the force in each member of the loaded truss by method of joints. So how we should be finding that out? So this is your step 1 here. This is your step 1. Okay. Here I am considering the structure as a whole and I am writing the external forces that are acting on it. So 30 kilonewton is acting at this joint. 20 kilonewton is acting at this position. This is position C. This is position A. And this is position E. At E, this is a hinged joint. This is a hinge joint. So EX is acting here and EY is acting here. And here some amount of tension is acting. Okay, some amount of tension is acting at this point. So now what I am doing is I am considering this structure as a whole. All the dimensions are known to me, 5 meter, 5 meter, etc. Now in step 1 what I am doing is if I take moment about E equal to 0, if I take moment about this point equal to 0, what should I get? Right? So this is my T. From T to E, what is the perpendicular distance? From tension T to E, perpendicular distance equal to 5 meter. You can easily see this one, isn't it?
Yes,
So
sir.
T into 5. So here I have 5T. Okay. That say here I am taking at point T clockwise as positive and anti-clockwise as negative, right? So this one will create an anti-clockwise moment at E, right? So minus 20 into perpendicular distance is 5. Again, this at force A, this will create anti-clockwise moment. So 30 into 10. So 30 into 10, that is equal to 0. From this, I get the tension force. I get this tension member. Just a minute. Right. Now, if I take summation of force in the x direction equal to 0 for this complete structure, what will I get? What should I get?
X equal to t cos 30 degree.
See here. Along this direction, I have Ex. Okay. And this is T cos 30. T cos 30. T is 80 kilonewton. So this is basically T cos 30. So T cos 30 minus Ex, that is equal to 0. From that, I get the Ex force. Okay. Now here, did you notice one thing? Here I considered a tension T. Why? I did not take any reaction forces or something here. Did you notice that?
Yes, sir.
Because this is just a connected member, not a hinged joint. So this is the symbol for hinge joint. Okay. This is just a connection. So since it is just connected to the wall, some tension must be acting on this member. Okay. Is it clear?
Yes, sir.
Yes, sir.
Right. So from this, I get the Ex force. Next, if I do summation Fy equal to 0, then what will I get? Fy will be, along this direction, I have T sine 30, right? So T sine
Minute, sir.
30
Excuse me, sir.
plus, yes,
Sir, in the hinge point E, there
this one,
should be,
point E.
yes, sir, there should be any reaction force.
Yes, here I have taken Ey Ex.
So, sir, in the okay, sir, clear. Sorry, sir.
Yeah,
Sorry, sir.
it's okay, no issues. So now I have taken T sine 30, okay, plus Ey is in this direction, plus Ey minus 20 and minus 30, right? That should be equal to 0. From that, I am getting Ey. Clear?
Yes, sir.
Okay. Now let us move to each of the joint and let us start solving. Say first I move to joint A. Okay. Let's say first I move to joint A. Say first I move to joint A. This is my joint A, right? 30 kilonewton is acting here. Say AB is acting in this direction. Okay, say AB is acting in this direction and AC is say acting in this direction. So what should I get? So how will I solve it?
AB cos 60 equal to AC.
Now see, this is an equilateral triangle. 5 meter, 5 meter, 5 meter. So each angle is 60 degree. So this is basically 60 degree, right? So
Yes, sir.
AB, so along this direction you have AB cos theta, right? So
Yes, sir.
0.866, sorry, this is your x direction, isn't it? This is your x direction. So AB sine theta, AB sine theta. So 0.866 AB minus 30. 30 is acting along this direction. So minus 30, that is equal to 0. From that, I get AB is equal to 34.6 kilonewton. T means tension. T means tension. Why? Because this is acting away from the joint. I had taken it away from the joint. Okay, so I get that to be 34.6 kilonewton in tension. Now, if I take summation Fx equal to 0, right, then then what will I get? So here in this problem, they have taken this direction as positive. You can take the opposite also. Okay, you can take the opposite also. You can take this direction as positive x. So AB cos theta, okay, 34.6 cos theta, that should be equal to AC. That is what they have done. That is what they have done. Okay, this should be equal to this. So AC is equal to 7.32 kilonewton compression. I had already taken it in the compression direction and this comes out to be positive. So the compression direction that I had taken, that is true. So 17.32 kilonewton compression. This is true. Okay, so I did not change the sign here. So at point A, all my forces are known to me now. AC is known to me, AB is also known to me. I have already found out AB and AC. Correct? Now I move on to joint B. I move on to joint B now. Now this AB direction, that was true for me. So here I will take force in this direction, AB. Okay. Now here they have taken BD along this direction. You can take this direction also to find out. Okay. Just try it. When you solve the problem, just take BD along this direction. Okay. And try to solve it. Say BD is in this direction and say BC is in this direction. Here AB is known to me now. So AB is equal to 34.6 kilonewton. That is known to me. BD is not known to me and BC is not known to me. And this angle is 60 degree. And this angle is also 60 degree. Okay. So now if I just solve it, first I take summation Fy equal to 0. From summation Fy equal to 0, I will get BC. So BC again, we are getting that to be positive. So the compression direction that I had chosen, that is true. So I am not changing the arrowhead. Now again, if I take summation Fx equal to 0 along the x direction, from that I will get the value of BD. So BD I had taken it to be in tension, right? And BD has come out to be positive. So I do not change the direction here. So the direction of tension that I had chosen, that is true. And I am not changing the arrowhead here. While when I give the PPT to you, when you will be solving this problem, take the direction in opposite. Take direction of B as opposite and see what is coming. Take BD in this direction, take BC in this direction. Okay. AB is already known to you. Take it in this direction and solve what happens. See if this comes out to be negative. See if this comes out to be negative. If it comes out to be negative, what will you do? You will convert BD in this direction and you will convert BC in this direction. Clear?
Yes, sir. We will reverse it.
Yes, yes,
We will
yes.
reverse it.
We will reverse it. Okay. We will reverse it. Now let us now move to the next joint. Okay. So here I had taken AB and AC like this. This is AB. And what was AC? AC was in this direction. This was AB. BD I had taken it along this direction. And this was your BC. Now coming to joint C. Now I come to joint C. 20 kilonewton is known to me. So AC now will be in this direction. BC now will be in this direction. Say CD is along this direction and say CE is along this direction. Say for instance. Now here this 20 kilonewton force is known to me. AC is known to me and BC is known to me. From this I have to find out CD and CE. Okay. So at joint C, if I take summation Fy equal to 0, okay, summation Fy equal to 0, if I take that, then what will happen? From that, I can easily find out CD, because here I will be having vertical component of CD, correct? And again, this angle is 60 degree. It is known to me, right? So CD, what will I get? And this angle is also known to me 60 degree. So this will be also 60 degree,
Yes, sir.
right? So here only CD is in positive direction. Vertical component of CD is in positive direction. CD Y direction. In this direction you have BC Y, and in this direction you have 20 kilonewton. So CD along Y direction, that should be equal to Y component of BC plus 20. So that is what they have done. That is what they have done. That should be equal to 0. From that I get the value of CD. Now CD again comes out to be positive, so it is, this joint is in tension, so the assumed direction is correct. Now if I take force balance along x direction, then what will I get? Along this direction I have AC, which is known to me. Along this direction I have CE, right? Along this direction again I have horizontal component of CD, okay? Right? And along
Yes,
this
sir.
direction, what do I have? Horizontal component of BC, correct?
Yes, sir.
So CE will be equal to summation of this, summation of this, and summation of this. That is what they have done. So summation of this, this, and this, that should be equal to CE. From that again I get CE equal to 63.5 kilonewton compression. So the assumed direction for me is correct, right? Now let us come to joint E. Let us come to joint E now. Let us come to joint E now. Now let us come to joint E. So this was your direction CE. So here I take direction CE in this direction. Okay. Your tension was in this direction here. Your BD is in this direction, and your CD is in this direction, right? Now when I come to joint E, okay, this is my reaction. What was EY? Equal to 10 kilonewton. So this is 10 kilonewton reaction force. Okay, this is CE. Say DE acts in this direction. Say DE is acting in this direction. Okay, and what was EX equal to? EX equal to 69.3 kilonewton. We had found that out. 69.3 kilonewton. So here I take 69.3 kilonewton. Right? Now CE is already known to me. At point T, this vertical reaction is known to me, this horizontal reaction is known to me. This angle is 60 degree, that is known to me. So vertical component of DE, that is equal to 10 kilonewton. Correct? From that I can easily find out force member DE. So I have easily found out DE. and my assumed direction in compression, that is equal. Now, just for checking, you can take summation fx equal to 0. For this is to perform check. Perform check. Now, summation fx, what all do you get? So, CE is in this direction, 69.3 kilonewton is in this direction, and this is DE, right? So, horizontal component of DE is in this direction. Horizontal component of DE is in this direction. So, CE plus horizontal component of DE, that should be equal to 69.3 kilonewton, right? This summation, if it comes out to be 0, then whatever you have solved, that is correct. Now I do not have to go to solve point D. Why? Because everything is known to me now at point D. As soon as I find point E, as soon as I find all the forces at point E, then I need not go to point D now. Because tension I have already found out in the initial step. BD I have already found out from joint B. This also, CD is also I have found out, and from equilibrium at joint D I have already found out D. So this automatically, this joint D, it is now completely specified. This is clear to you?
Yes, sir.
Yes, sir.
Right. So in my tutorial class, we will be solving more numericals. Okay. In the tutorial class, we will be solving more numericals. So let us just sum up. Let us just sum up. So here, here we have learned about trusses, and we have defined a truss, and we have said that each of the member, they can be in tension or they can be in compression, and they are considered as two force members. For equilibrium of two force members, what do we have? The two forces are applied. So the two forces are applied at the ends of the member and are necessarily equal, opposite and collinear for equilibrium. The member may be in tension or the member may be in compression. Okay. Now, if I take a cut section at any point, then the force acting at that will be same. Next, we saw how to draw the free body diagram of the structure as a whole. And after that, what are the internal forces acting on each of the member? We found that out by using method of joints. Right? In method of joints, we found out from step 1 the reactions that are acting, and in step 2 we move to each joint, we give the necessary direction of the force, we take arbitrary direction of the force. If it comes out to be positive, we do not change the direction of force, and if it comes out to be negative, we change the direction of the force. Likewise, we move to each and every joint. So which joint we begin with first? Where at least there is one known load. So I proceed with joint A first, then I move to joint F, then I move to joint B. Next, I can move to joint E, and then finally I can move to joint D. Step by step, I can do that so that I can find out each and every force in the members. This is basically your method of joints. Next, we saw how to solve one problem. Here we had taken along this direction a tension. Here there is no joint. This is just a connection. This is just a linkage. It is perpendicular. So from step 1, we found out the value of the tension, the forces, the reactions at E. Okay, EX and EY at E, we found that out. Next, we move to each and every joint, starting from A. From A to joint B, then to joint C, and then we moved on to joint E. Eventually, we saw that joint D becomes completely specified in the last step. So is it clear to you? The method of joints?
Yes, sir.
In the next class, we are going to solve one or two more numericals, and on Friday, we are going to learn about method of sections, and we are going to complete trusses. Next, we will move on to, in the next week, we are going to move on to strength of materials. Actually, this module is such a long module, it is taking a lot of time. Okay, so kindly bear with me, because these things, if I do not teach you, you will not be able to solve numericals in your exam. Okay, the last module is mostly theoretical, so I will try to provide you notes on that. Self-explanatory notes I will try to provide you, so that you can start preparing as soon as possible for module 5. It is completely theoretical. Okay, and where you have such numerical solving exercises, first I will try to complete that, because if I do not teach that to you, you won't be able to solve numerical. And the theoretical portions, you can do that self study. Okay, in this manner we are going to proceed. Any questions, students? Any questions?
No, sir.
Sir, trust is in module 1 or module 2?
It is in module 1. We haven't completed module 1 yet. After that, you
Okay.
have strength of materials in module 1. Then you have moment of inertia in module 1. So it will take at least 4 more classes to complete module 1.
Okay, sir.
Then we are going to move on to module 2. That is also huge. Huge. Okay. So we'll try to complete it in 3 months. You have to work hard, and I also have to work hard for that. Okay. So if you do not have any more questions, so you
Excuse me,
can
sir.
leave for today. Right?
Excuse me, sir.
Yes.
Sir, I lost my connection when you were explaining that. What is capital T and capital C?
Where? Where?
CD is equal to 57.
CD is the force in member. This is your link CD. This is your link CD, isn't it? So the force in member CD, that is denoted by CD.
No, sir, I'm
C
asking
and D is not
what is
different.
capital T?
Huh?
Capital T.
Capital C, capital D. This is naming. Say you name straight line CD. So this is the
No, sir,
member CD.
capital T. Capital T.
Capital T. It is 57.7 kilonewton in tension
Okay.
at this joint. See, CD is in tension. The force CE, it is acting towards the joint. So that is compression. Clear? So CE, here C, it is written capital C. It denotes compression. Clear? You have to mention that if the force is in tension or compression. Is
Okay.
it clear to you?
Yes, sir. Thank you.
Great. Okay, so again we are going to meet in the next class. Right? So you can leave for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.